Hello, class. This is going to be our first lecture on logic. So logic is the mathematical manipulation of ideas. So it's the way that we take ideas and combine them together in a structured, organized kind of way. Okay? So it's very useful for thinking about things, and it's really kind of the foundation of mathematical thought. So what we're going to talk about is some ways that you can use logic in the real world, some applications, different things that you can do with it. And so we're going to start with the idea of a logical statement. So a logical statement is a statement which is either true or false. Okay? So it can be demonstrated that it's true or false. We may not actually know whether it's true or false. For example, it might be something like I will receive a package today, right? So that statement is either true or false. I hope that it's true. I have something that I'm expecting to come today, right? But I don't know yet whether it's true or false. I'll know by the end of the day, right? So what matters is that it's actually something that has a value. It's either true or false, okay? Examples of things that are not logical statements. So an opinion is not a logical statement. Like, so if I said, that TV show is bad, that's my opinion. That's not a true or a false statement, right? It's not something that it can actually be determined logically. A lot of statements in mathematics are logical statements. So like if I say the number 3 is even, that's a logical statement. Now it's false, right? So even, remember, means that it's divisible by 2, like 2, 4, 6 are your even numbers. So the number 3 is even is a false logical statement, but it's actually a logical statement, okay? And so lots and lots of things in mathematics. A triangle has 3 sides. That's a logical statement. That one's true, right? And so lots of things in mathematics are logical statements. Another example that's something that's not a logical statement is what's called a paradox. So if I wrote up this statement is not true, this is called a paradox, and it's a problem because if you think about it for a second, if this statement is true, well, then the statement refers to itself as being not true. So if it's true, then it's false. But if it's false, then it's true. And so there's no way that this can actually be true or false. It can't have one particular, what we call a truth value. It can't be one or the other. And so a paradox is not a logical statement. Okay, so this is called a paradox. So it's something that can't be true or false. Okay? But what we're going to do with logical statements is we're going to manipulate them in different ways. Okay? So what we do in logic is a lot of times we try and form an argument, or what's called a proof. And so a logical argument or a proof is a collection of logical statements that make sense consistently, that you can combine all together and they're all true, and then you find out something else at the end. Okay? We're not actually really going to write proofs in this class. We're going to take it that far, but we want to talk about some of the elements. Okay? And so one thing I want to talk about that's useful is combining logical statements, combining and modifying logical statements. So if we have 2 logical statements, we can put them together in a couple different ways. We can use the words and, or, and not. So these are logical modifiers. And so what and does is it puts 2 statements together. So and combines 2 statements and gets a new statement which is true if both of the originals are true. Okay? So we're going to take two statements and we're going to get a new statement, and that statement will only be true if both of the original statements we started with were true. So for example, if I said x is odd and x is less than 10. Okay? So this statement would only be true if our number x is an odd number and it's a number less than 10. So if x is equal, let's assume that it's greater than 0 and ignore negative numbers. If x is equal to 1, 3, 5, 7, or 9. Okay, so these are odd numbers, so they make this statement true. They're less than 10, so they make this statement true. And so the whole thing is only true if x is equal to one of these numbers. If x is equal to 2, then this statement is false. Okay, and so the whole thing is false. If x is equal to 13, this statement would be false, and so the whole thing is false. Or if both are false, the whole thing is false. Okay, so if you have a statement and another statement, the whole thing is only going to be true if both of the statements are true. Okay, so the next word we've got here, or, is different. So the way that or works is it combines two statements. So A or B is true if either or both are true. Okay? And so, for example, if you had x is less than, let's say x is, less than 7, or x is greater than 9. This statement is going to be true for any numbers other than, so this is true if x is not equal to 7, 8, or 9, right? So for example, if x is equal to 3, this statement is true. If x is equal to 12, this statement is true. Now, if x is equal to 12, this one isn't true, but we only need one of them to be true, okay? So one or both of them has to be true to make the whole statement true, okay? Let's do another example. Let's say x is less than 10 or x is greater than 5. So if you think about the numbers that make this statement true, anything less than 10 will make this true. So 1, 2, 3, 4, all the way up to 9 makes this true. Or if x is greater than 5, this is anything bigger than 5. So 6, 7, 8, 9, 10, all the way up to infinity. And so if you think about this, if you take any number, so this is true for any x, right? Because if it's something smaller than 5, it fits in this one, right? 1, 2, 3, 4, or 5. These are all here. If it's something greater than 5, it fits this one, 6, 7, 8, 9, 10. And so this is going to be true for anything. Okay? So, the difference between and or is just in whether you need both of them to be true or just one or possibly both of them to be true, right? So if you said, for example, 3 is even and 3 is less than 10. as opposed to 3 is even or 3 is less than 10. Okay? So in both cases here, this piece is true, right? 3 is less than 10. This piece is false, okay? Because 3 is not an even number. If you take false and true, that statement is false. 3 is even and 3 is less than 10 is a false statement. But if you say 3 is even or 3 is less than 10, that's a true statement. Okay? So that's the difference between here. You just need one or both of them to be true. Now, one thing to watch out for is that the way that we use or in English doesn't always match up with this. So if you, for example, if you tell a little kid, you can have cake or candy for dessert. Okay? If you said this to a 6-year-old, for example, you mean that they can have either cake or candy. They can't have both. Okay? But to a mathematician, the word or always means one or the other or both. Okay? So if that 6-year-old is a mathematician, watch out, because they're going to say, okay, I'll have cake and candy, because that makes the statement true. Okay? So it's just a difference. We use or in both what's called an inclusive, which means one or the other or both, or an exclusive way in English. So just be careful. Sometimes this doesn't work out exactly to match out with the way we think of the word or. In mathematics, we will always use or to be this statement, or both are true. Okay? The last thing we have to talk about here is not. So not A is always the opposite of whatever we're talking about. So if, for example, I say 3 is not even, as opposed to 3 is even. So what not does is it changes the truth value. So for example, 3 is even is a false statement. 3 is not even is a true statement. It's the opposite. Okay? So one way that these quantifiers can be used is in web searches. Okay? So Google understands and or and not, and you can use them to kind of refine your web searches. Okay? So if, for example, you're looking for something and you want to look for both terms always, okay? So if you add the term and, what that's going to tell Google or another web search is that I want to look for both this and this. So for example, if you were looking for, say you were looking for a bakery that sells Smith Island cakes. Okay, so if you're not from Maryland, Smith Island cake, they're from the Eastern Shore. It's a particular kind of cake. If you just search for Smith Island cake bakery, you will get a lot of results, almost all of which are in the Eastern Shore. There's one in Salisbury, there's a few on Smith Island, right? It's not necessarily useful if you're looking for one in Baltimore, okay? So if you add to this and Baltimore, you'll get results for Smith Island cake bakeries that sell these cakes in the city of Baltimore. So adding in that and can give you specific results and kind of add other things on. Okay, so this is useful if you're looking for two different things and you want pages about either. So for example, say back when sports were a thing, maybe you're watching this video and organized sports are again a thing. Say you want to go to a sporting event in Baltimore, but you like football and you like lacrosse. You could search for Baltimore football or lacrosse, and get a list of events that are coming up that are either football events or lacrosse events, okay? And so you get either. Another example, if you were looking for somewhere to play lacrosse, and you're like, well, I don't care if it's a football field or a lacrosse field, you could search for football or lacrosse field, and all of them will come up, okay? So that can be really useful. Not is probably actually the most useful. So if you use this in Google, it's actually you use a minus sign to indicate not. And so this can be really, really useful if you're looking for something and it's very much associated with another word. Okay, so for example, Smith Island is a place on the Eastern Shore. It's down toward the tip of the Delmarva Peninsula. It's an island. It's an actual place. It's very famous for these cakes. And so if you just Google Smith Island, like your first 20 results will be about cakes. And maybe you want to actually go to Smith Island. Maybe you don't want a Smith Island cake. If you add on there minus cake, this will give you other results for Smith Island that don't have to do with the cake. Okay? So I use this all the time. So I'm lactose intolerant. I can't digest dairy. And so when I'm looking for recipes online, I'll look for a recipe for something like banana bread, and then I'll put minus dairy or minus milk or minus cream or whatever. So I can find recipes that don't actually have any milk in them. And so that can be another kind of example of a way that you can use this. Okay? In our next lecture, we'll talk about quantified statements. So that video is coming up next.